Okay guys, so for this problem I want to compute integral of cosine of ln of x, and what is the approach? Approach is just first apply the u sub. The only choice for our u is when u is going to be equal to ln of x, then you can see that du is going to be equal 1 over x dx, or in other words x times du is equal to dx. But since u is equal to ln of x, then I know that x is equal to e to the u by definition of logarithm. Or in other words, that dx is going to be equal e to the u times du. And then I'm going to rewrite my integral. So what I'm going to get? I'm going to get cosine of u times dx, but dx is e to the u times du. So that's why I'm going to write it down. And when we have the integral of cosine u times e to the u, then the idea is to use integration by parts. But I'm not going to use integration by parts once, I'm going to use it twice, and you will see why. So first I'm going to set x to cosine u and dy to e to the u. I chose x and y just as variables for integration by parts, so it's not like x and y from it's not like x from the previous original integral cosine of ln of x. I'm just use that as intermediate step. And then you can see that dx is negative sine u and y is going to be e to the u. So by integration by parts I will have x times y, which is e to the u times cosine u, minus integral of y dx. So in other words, e to the u times sine u. And since we have negative in front of sine, that is going to give us positive with a negative in front of the integral. And then I need to do integration by parts again. And I'm going to use the same choice for x and y, but in that case I'm going to have sine u and e to the u. And again, if I'm going to multiply x by y, what I'm going to have e to the u cosine u plus e to the u sine u minus the integral of e to the u cosine u. And here you can observe if we're going to look at our our integral e to the u cosine u, then by doing integration by parts twice, we're going to end up with the same integral on the right hand side with a negative sign. So that's why literally what I need to do, I just need to move my integral from the right hand side to the left hand side, and I'm going to obtain that 2 times integral e to the u cosine u du is equal to, I'm going to factor e to the u, so I'll obtain e to the u times cosine u plus sine u, and never forget what we should get plus c. So what we're going to get plus c, if we're going to divide both sides by 2, I will get that my integral is going to be equal to e to the u over 2 times cosine u plus sine u plus c. But here we have u is equal to ln of x. So what do I need to do? I need to plug in my x back, because I want to get the answer just in terms of x, since we start as a function in terms of x. And here we're going to have integral of cosine of ln of x is equal to, since e to the power of ln of x is just x, I'm going to have x over 2 times cosine of ln of x plus sine of ln of x. And always remember that we need to choose plus c. So you can see that at the first, that real scary integral is actually not as bad. It just requires you to do one time u sub and apply integration by parts twice.